we need to solve this rational expression, which means we need to figure out what x is equal to. And the first step is here, factor the denominators to find the lowest common denominator. That's exactly like you do with adding and subtracting. So there's no difference there. Let's do that factoring. I'll leave this the same, x squared plus 25 over x minus 7, because I don't have to factor that, plus x plus 5 over 2, because that also can't be factored. But the last one I think I can factor. All I can do here is factor out a 2. But what is the lowest common denominator going to be?
2x minus 2? Or not minus 2 minus 7.
2 times x minus 7, right. So the lowest common denominator, I'll put it here, is going to be 2 times x minus 7. But this is where it's a little bit different than the adding and subtracting. Rather than changing all the denominators, what I want to do is get rid of the denominators. So that I turn it into something that I already know how to solve, either a linear or a quadratic equation. So to do that, I multiply each term by the lowest common denominator. So I'm going to multiply this by 2 times x minus 7, and then this by 2 times x minus 7, and this last one by 2 times x minus 7. And it's not multiplying it by 1. So it's not 2 times x minus 7 over 2 times x minus 7. It doesn't need to be, because it's an equation, and as long as I do it to each term, then I maintain that equality. Remember, when it was an expression, you can't just randomly multiply by a number or an expression, but in an equation you can, because I do it on the left side and I do it on the right side, and everything stays equal. But here's the nice part where it simplifies. When I take that first term, x squared plus 25 over x minus 7, and multiply it by 2 times x minus 7, the x minus 7's cancel out, and I'm just left with 2 times x squared plus 25. And when I multiply the next term, what happens? The 2 cancels out, right. So that 2's gone, and that's 2 is gone, so I have plus x minus 7 times x plus 5 equals, and in the last one, everything cancels out, so it's just 2x squared minus 12x minus 9. And what we've done by multiplying by the lowest common denominator is we got rid of the denominators, and we're left with something that, even though it looks long and complicated here, it is something that you know how to solve, because it's quadratic, and you already know how to solve a quadratic equation. So the third step then is expand, simplify, and solve. No, we won't do that yet. Expand, simplify, and solve. So I'll multiply this out, 2 times x squared, 2 times 25. Multiplying this, x minus 7 times x plus 5, I get x squared plus 5x minus 7x minus 35 equals 2x squared minus 12x minus 9. Combine like terms. So on the left I have 3x squared. So that's that and that. How many x's do I have? Just those ones. So negative 2x. And then plus 15. So that's the expand and simplify. I want to try to solve this. You're going to have 2 different strategies here. One strategy for if it's a quadratic and one for if it's linear. This one's quadratic, so move everything to one side. If it's linear, you isolate the x, so move everything away from the x. But for a quadratic, so I'll subtract 2x squared from both sides, so I get x squared. And negative 2x, and I'm going to add 12x, so plus 10x. And then 15 plus 9, so plus 24 equals 0. That's what it simplifies to. And how do you solve a quadratic? Factor? Probably factoring is going to be your method of choice. Oh, this one's not too bad. X plus 6 and x plus 4. Okay, so the last, we didn't finish solving. We say x equals negative 6 and x equals negative 4. So last step, check solutions for non-permissible values first, because that's the easiest way to find an extraneous solution. Is if your solution is one of the non-permissible values, well then that's not permissible, so it can't be a solution and you get rid of it. But non-permissible values here are, just 7. And since we didn't get 7 for a solution, I'm not even going to bother writing out the non-permissible values. I'm just checking to see, is one of my solutions a non-permissible value? Because if it is, I'm going to discard it. But it's not, so we'll leave that. And then we need to check for extraneous solutions. And we do that by taking those values that we got, x equals negative 6 and x equals negative 4, and filling them into the original equation to see if it works out. When I fill x equals negative 6 into the original and simplify both sides, I get this. Negative 5.19 equals negative 5.19. So what does that mean? It works. So that is a solution. Now I have to test the negative 4 by filling it in. And when I fill in x equals negative 4, I get negative 3.73 equals negative, that's not what it equals. I'm looking at the wrong line. Negative 3.23 equals negative 3.23. So, they both work. This one's not so bad. So it's for you. Well, it's not as much work as the first one. The only thing I will tell you, you may want to go 2 over 1 first. The common denominator here will be x minus 4, so we have to multiply each term by x minus 4. In the first term, the x minus 4's cancel out, so you just have 5x. In the second, they don't cancel, so you have 2 times x minus 4. And then in the third one, they cancel again, so 3x minus 8. So expand and simplify. 5x plus 2x minus 8 equals 3x minus 8. I'm going to move the x's to one side and the numbers to the other. So I have 5x plus 2x minus 3x, which is 4x. And then I'm going to add 8 to both sides, so I have negative 8 plus 8, which is 0, which means that x equals 0.
Right. That's what I got.
It's not a non-permissible value, right? Because it says x cannot equal 4. Well, x doesn't equal 4, so we're fine. It equals 0. Then I need to check it and see if it's right. This one's easy to check because it's 5 times 0 over 0 minus 4, which is just 0, plus 2.
What is y plus 2?
That's the second term.
Right.
Is just a 2. Equals, 3 times 0 minus 8 over 0 minus 4. So negative 8 over negative 4, which gives me
2.
2 equals 2. So that looks good. That's the answer. You guys can also try this one. So far what I did was factored the denominator in the third term, found the common denominator, and then you multiply every term by the common denominator. So every term gets multiplied by x plus 2 times x minus 3. But what happens is, like, the x plus 2 cancels out in the first one, so I get 3x times x minus 3. The x minus 3 cancels out in the next one, so I get minus 5 times x plus 2. And then they both cancel out in the last one, so it just stays as a negative 25. When you do that, when you multiply through by that common denominator, it simplifies things a lot, because it makes it into something that we already know how to work with. In this case, a quadratic. So I'm going to expand. This will be 3x squared minus 3x, minus 9x. And then minus 5x minus 10. And I'm just going to go plus 25 equals 0. So I'll move that 25 over in the same step. And now combine terms, 3x squared minus 14x plus 15 equals 0. Then I want to try to factor that. So you use whatever method you want to factor. We end up with this, 3x minus 5 times x minus 3. And so the x minus 3, that's easy. You get x equals 3. But for the other one, 3x minus 5 equals 0 is how you do it. So then solve for x and you get x equals 5 over 3. So two solutions there. Check for non-permissible values. X cannot equal negative 2 and 3. So we reject that x equals 3 because it's a non-permissible value. X cannot equal 3. And we have just one solution there. X equals 5 over 3.
Wait, why do you get rid of the x minus 3?
I got rid of the x minus 3 because if you look at the non-permissible values, x cannot equal negative 2 and x cannot equal 3.
But how does that get rid of the...
Because it said x equals 3 and I said x cannot equal 3.